There we go. Students will be able to use the corresponding angles converse. Students will be able to construct parallel lines. We're not going to construct parallel lines very much, well, at all today, because we're not going to do constructions. We're not getting out our compass and all that stuff to work on constructions today, at least. We'll be able to prove theorems about parallel lines. So we talked about yesterday that we're not going to do actual legit proofs. We're just going to show that what we're saying, that we can back it up with those explanations. We're going to cite our theorems, and we're going to use our theorems and postulates to show that what we're saying is true. Last one, students will be able to use the transitive property of parallel lines. That sounds really complicated, the transitive property of parallel lines, but it's very, very simple. I think you guys are going to be able to come up with that property without me even telling you. You'll see when I'm talking about when we get there. So we have a review. We're looking at some more theorems. Like I said, you're going to want a running kind of couple pages of notes that include theorems because we're going to keep looking back at these different theorems. So we're adding a few more to that, and then we're going to practice. So first, what is a converse? Besides a shoe brand, or shoes and clothes, besides a shoe brand, in math, do we know what a converse is? There's no reason that you would have heard of this word before. It's not like you're supposed to know this. I just want to see. Converse. That's okay. So if we have a sentence like this, if two line segments have the same length, then they are congruent. So I should probably write this down. Otherwise, I'm going to give my words out, and I think they're just going to become a mess. So if, let me get this right on. Two line So if we have a sentence like this, if two line segments have the same length, then they are congruent. Its converse would be this. So if we have an original statement, and it says, if two line segments have the same length, then they are congruent. When we are talking about its converse, it would be this statement right here. We would switch it around. If two line segments are congruent, so we take this end and put it to the beginning, if two line segments are congruent, then they have the same length. So what we're doing with a converse is it's saying we have an original statement, or original theorem, and we're just kind of flipping it around. Now in this case, our converse makes sense. Our converse is something that makes sense. That if two line segments have the same length, then they are congruent. On the other hand, if two line segments are congruent, then they have the same length. Right? We're saying the same thing, just in two different ways. Sometimes our converse is something that doesn't really fit. So here's an example of that. So in our first case, the converse made sense. Right, here's our converse. In the second case, our original statement, if you are a guitar player, then you are a musician. Okay, that's fair. If you are a musician, then you are a guitar player. So when we switch it around, if you're a musician, that doesn't necessarily mean that you have to be a guitar player. You could play a lot of other instruments. So really the idea that we're trying to get at is a converse is when we take the beginning of the sentence and we put it to the end. We take the end of the sentence and we put it in the beginning. Okay? And these two examples, I put two different examples up because our example over here, that still makes sense, right? The converse is still true. We're still good. And over here, we don't have a math statement, but the converse doesn't really make sense. It's not really true. So again, the idea of a converse is just switching those sentences around. And the ones we'll look at will make sense, but once in a while, they won't totally fit. You might have to think twice about it. Okay? And right now you're probably thinking, what the heck is he talking about? This is a small part of our lesson. You're just going to see the word converse a lot, so I want you to have a little bit of a background on what that word means. Converse is something we would talk a lot about in chapter 2. But does anyone remember what we did in chapter 2? Kaylee, what did we do in chapter 2? We skipped it, that's right. We skipped chapter 2. So, let's look at our theorems for today. Don't get caught up on the converse thing. If you're like, what is he talking about? Then we'll get to it. Don't worry. So, we're using the angle converse. So far, when we've had our transversals like this, or I guess yesterday, we told you right off the bat, come on, there we go. We told you right off the bat that these two lines are parallel, right? Yesterday, that's what we talked about. If these lines are parallel, then we have certain relationships within our angles. Then we have all those alternate exterior, alternate interior, all that kind of stuff. Today, what we're going to look at is they're saying, hey, we're not going to tell you if these are parallel or not. J and K, we're not going to tell you if they're parallel or not. What we're going to tell you is some angle relationship. And then we have to decide if these two lines are parallel. So the first theorem goes right along with what we've talked about. The corresponding angles converse is what our theorem would be called. And all that says is that if we have corresponding angles, if they give us corresponding angles, then we can know that these two lines are parallel. How are we doing? I'm seeing a lot of blank faces. Taylor, how are we doing? We're getting there a little bit. You'll kind of, as we dig into it more, you'll see where this idea of a converse comes up. But again, yesterday we said these lines are parallel. J and K, yesterday we said J and K are parallel. So that means that angle 2 and angle 6 are corresponding angles. That's what we learned yesterday. Today, we're kind of looking at the other side of it. We're saying if angle 2 and angle 6 are the same, if they're corresponding angles, then that means that line J and line K have to be parallel. A hand, or is that a stretch?
No, I'm moving my hair.
Your hair?
Yeah.
The luscious locks?
Oh,
We
yeah.
get it. Let's look at another one. Another angle converse is theorem 3.6. Now in this one, you'll probably just want to write and draw one transversal, just like we have been the last couple of days. Draw one of them, label all the numbers, and then put like your theorems on the side. Sorry, I should have mentioned that at the beginning. So you want that picture up. Isabel, what I mean by draw the picture. I know you were here the last 2 days to see the picture. But what I drew there in blue, that's what we call transversal. And you just want to label it. And those numbers just represent each of those angles. So we're going to talk about different relationships. So what you might want to do is then write theorem 3.6, alternate interior angles converse, and then just write angle 4 and angle 5. And so you don't have to keep drawing the picture. Just have the picture with all those numbers in it. So with theorem 3.6, alternate interior angles, it's saying, hey, if we have alternate interior angles, if they show a picture and it says angle 4 and angle 5 are the same, they're congruent, then we can know that line J and line K are parallel. So our name stays the same, right? 4 and 5 are alternate interior angles. We know that. Or they're telling us that in the picture. Now for this theorem, we're just adding the word converse on the end because we're changing our perspective. We're saying that we have alternate interior angles, so that means that line J and K are parallel. You probably are going to start seeing the pattern here, but theorem 3.7, alternate exterior angles converse. If we have alternate exterior angles, then we can know that J and K are parallel. Second to last theorem that we're looking at today, consecutive interior angles. If we have consecutive interior angles, so if they tell us that angle 5 and angle 3 add up to how many degrees, Haley? No, you're good. If angle 3 and angle 5 add up to 180 degrees, they're consecutive interior angles, and then we can know that J and K are parallel. Are we starting to kind of see the idea here of what a converse is? A little bit? Or are we still writing down so we can think about that? I think I get used to our class times. 29. Perfect. Just as a public service announcement, while you guys are finishing writing that down, on that board to the left, I'd like to start to get pictures of you guys in the paper. If you ever do anything cool in the paper, or I don't know, whether it be pictures and articles, whether it's sports or something in the community or an activity like that, I need decorations on that board. I think clips from the paper or something would be cool. Or if I notice some, I'll cut them out and bring them in. If you see yourself in the paper for anything, like if a house is burning down and a child is in there and Sawyer runs in and saves the child, then when he runs out, baby in hand, they take a picture of him and he's got like half his nice head of hair burned off. That'd be a cool picture up there. I'm not saying you should do that right now.
No, I'm saying it wouldn't be worth it.
To burn half your hair? Yes, it would. Alright.
I have little clippings from the newspaper from when I won the geography people took third place.
That's a pretty big deal.
What
Some examples.
You don't want those photos, isn't it?
Well,
I remember when Trey was like, I don't know the answer, but I just said you could That's hilarious.
moving on from our public service announcement. You're probably thinking, how are we going to use this in a problem? Oh, we forgot to do our corrections, didn't we?
No.
For 3.2.
No.
Yes, we did.
100%.
Yes, we did. We forgot.
No, we don't get 100%.
I
Remember?
mean, probably.
Remember that?
Probably. We'll do that right after this. You're probably thinking, how are we going to use this? Well, here's how. Find the value of x that makes line M parallel to line N. So they didn't tell us they're parallel. We have to show and find what x would have to be for those two things to be parallel. So, what relationship do these guys have? I'll just circle it in white. But do 135 and 2x plus 15. What relationship do they have? They're corresponding. So what does that mean? They're the same. They're congruent. So we could do this. Right? We set them equal to each other. And this is because they are corresponding. Now we set them equal to each other, and we would find that x equals. What do you think it equals? I think it would be less than that. I wrote it down. I think it'd be 60.
Oh, yeah.
We find that x equals 60. Yep. So if x equals 60, that means that those angles would be congruent. They both would be 135. And if we have corresponding angles, that means that line M is parallel to line M. So very simple, I mean, almost the exact same thing we did yesterday, right? We're just looking at it from a different perspective today. And explain your reasoning, corresponding angles. That's my reasoning. Second set of questions. Decide whether there's enough information to prove that M is parallel to N. If so, state the theorem you would use. So in this first one, do those two angles have a relationship? Two little red. They're alternate interiors. So is that enough to say that that the lines are parallel? What did our theorem say? If we have alternate interior angles, then do we have parallel lines? Yeah, we do. Yes. Now look at the second picture. What type of angles are those? What relationship do they have? Vertical. Are vertical angles enough to say that we have parallel lines? Is that one of our theorems? No. So even though they have a relationship, it's not enough to say that we have parallel lines. So decide whether there's enough information. The second one, there's not enough information. That's all we need to put. Not enough info. This so state the theorem. Well, in the first one, there's enough information, and it was because of alternate interior angles. Now how are we feeling about this stuff? Good? Fine? It's really not that different from what we did yesterday. Well, we'll find out in practice. Do we have any questions? One more theorem we need a quick look at. Now I'm going to see if you guys can help me out. The transitive property of parallel lines. It says if we have a line, and it's called P, and it's equal to Q, and then if we say that that line Q is equal to line R, then what is the relationship? So P is equal to Q, Q is equal to R. What is our relationship of P and R? Same thing? They are what then? Congruent or equal. Yep, very good. So the transitive property, come on, there we go. What? The transitive property of parallel lines says that if P is equal to Q and Q is equal to R, then P and R are equal to each other. And you may just want to write that down, even if you just want to write the picture down. And that is theorem 3.9. And that's how the book says it right there. So, here are the problems that I would like you guys to do. And then I'll have you bring them up to me. I will check them. And once we are on the same page with things, then you can have the one-page worksheet. When you come up to, why don't you bring your homework from yesterday and we can quick check that and you can give it to me. And everyone can get a 10 out of 10 pretty easily.
So right now we're just solving those three.
Right now, do these three. Once you're done, or if you have questions, I can take a look at them. And when I take a look at these, I'd like to see your homework from yesterday too. So we'll knock that out really quick.
You mean to leave your thing still recording, or is that just how it's processed?
Good call.